Stanford University.
Welcome, CS193P, Lecture 16. Today we're going to talk about a subject that's dear and near to my heart, which is audio and video playback as well. So we're going to get into some APIs there. We're not going to talk about web content. I guess I didn't update that slide. But we're going to talk a little bit about settings and how to add application settings into the Settings app for your app. We'll just talk about the announcements. So the announcements for this week. First things first, Paparazzi 4 is due this Friday, 11:59 p.m. So make sure it's done. Any questions about Paparazzi 4 before we move on? So as you know, you're going to need to. Hopefully everybody's read the assignment at least. You're going to need to integrate address book into this, and threading. Threading is going to be a big part of it as well. And we've asked you to build your own feature into there. So come up with something that's appropriate to you. It doesn't have to be very in-depth. It just needs to be something unique. Use something from WebKit and show us how you're using it, and point it out in your assignment. So, sorry, not WebKit, UIKit. Sorry, something from UIKit. You could, for example, a web view. I think that's where I got my head backwards. You could use video or audio if that makes sense to you.
What if you do something like extending the Flickr API and it's not specifically involving UIKit? Is that fine?
If it's a cool feature for your app, then I would encourage you to go for it. Yeah. So, okay. So, next assignment actually is that your final project proposals. Hopefully, you have all received feedback. If you haven't, please let us know. We think we've sent them all out. We've got about 2.5 weeks left before those are all due. So they need to be ready. And the last thing is this Friday, we're actually going to have the folks from Bump here to talk tomorrow in, what's the 260? 113. They'll be talking. So they're actually going to discuss a little bit about their business, but also an API, an SDK that they're coming out with. So if you'd like to use Bump in your final project, there's an opportunity there to find out what they're doing. And if you don't know, Bump is this app where if two people have phones and they're running this Bump app, when you bump the two together, it actually hits the cloud and exchanges address book information. So pretty cool. And I don't know the details of their SDK, but I presume it has something to do with that recognition of two devices. So come check it out. It should be cool. And before I dive in, the folks at A-Press, actually Dean Kaplan himself sent us a bunch of cool swag that I'm going to give out today. The first is this iPhone application sketchbook, which is essentially, a graph paper. It's a sketchbook. It's exactly what it advertises. But it also comes with a stencil, which is pretty cool. So if you want to draw some standard widgets, sliders, all that stuff, yeah, these two go together. So if you're, if you're lucky, if you can answer some questions during this, you'll get one of these, a pair. We've got about a half dozen to do. So, all right, let's get started. So again, today we're going to talk about audio APIs. Yes. Oh, yeah. Thank you. Sorry. I'm in Josh's role from last week. So the TAs, we need TAs for next term. If anybody's interested in being a TA for next term, please email us or go through the standard TA process, which may have already shut down for the term. Okay, so it's too late for the standard TA application process through the school, but if you email us directly, we can get you through.
Only for grad students?
Question is it only for grad students? And no, it's not. I don't think so. Is it? Yeah, I don't think so. If I'm wrong, I'm wrong, but...
Undergrads can be TAs, but I think grad students have preference if they need it for funding.
Okay, so grad students have preference if they need it for funding, but yeah, I think anybody's open to apply. So, but you need to do well in this class for us to consider you, so hopefully you're all studying hard. Okay, today we're going to get into audio APIs. We'll talk about how to play back audio, how to record audio, and how to use the media player APIs for doing iPod playback. We'll talk about video playback and the video editor. So there's a video editor class for doing, if you've ever recorded a video on the phone, you can go and trim those. There's actually an API for you to be able to get to that UI as well. And we'll talk a little bit about settings bundles, which is something that, pretty pretty fundamental to applications, and we've saved till right at the end to talk about it. But it may be useful for your final project, so I want to talk about it today. First things first, audio playback. Lots of different things you can do with audio, right? You all used apps on the phone. You've seen different uses. You could do sound effects for button clicks. You can do alert sounds when somebody does something that they weren't supposed to do. You can play music. You can stream audio. You can also play back audio through the iPod app. You can record audio as well, so you can get audio off the mic and then save that to disk. And I'll show you how to do all those things today. There are a few different subsystems for doing this, and I'll take you through all the different ones. The question is, with all these different subsystems, is which one do you want to use? And the answer to that is that it depends how complex the task is that you want to do. So if you're if you're playing back short sounds, there's one set of APIs to use. If you need mixing of different streams of audio, that's another set of APIs to use. If you need, there's about 4 or 5 different APIs. If you need like spatial rendering, that's another set of APIs. But one thing to note about all this stuff is the device is a phone first. Before anything else, it's a phone first. Right? So the system manages the sound. You can play back if you want, but you're basically recommending to the system how you want to play the sound. If the system decides that it needs to take over the audio because your user's on a phone call, your sound is going to go dead. And I'm going to show you how to respond to those kinds of notifications to make sure that you do the right thing. Right? So let's get into that. Few different, under the hood, there's a very important technology at play here, which is called core audio. Now, core audio it's the same audio processing that happens on the desktop. So, as many of you may know, if you go to any or most major recording studios use Mac to do their processing. A lot of the most of the high-end audio processing and applications for the Mac are actually based on core audio. And it's a very flexible, very powerful set of APIs. Now, on top of core audio, there are a few different levels of abstraction. For very easy-to-use sound processing, you have the system sound APIs. For a little more Objective-C friendly, there's a simple API called the AV Audio Player, and that's great for playing songs, for example. And now lower level, there are 3 that we're going to get into. One is the Audio Cue APIs, which come from the Audio Toolbox. And Audio Toolbox has some other tools in there for doing file parsing and stuff like that. There's audio units themselves. So audio units are these node-based processing engines, kind of the core of core audio. And then there's OpenAL, which is an open standard, just like OpenGL, which I'm sure you've all heard of. OpenGL used for rendering video in a standard way across devices. There's OpenAL for doing spatial rendering of audio. So now, to decide which of these you want to use, you have to know a little bit about each one and what the properties are of each. So we'll start with the System Sound API. Okay? If you want to play some short sounds, we're talking about user interface sounds here, less than 5 seconds each. The System Sound API is what you want to use. Now, it doesn't provide things like looping. Okay? So you can't have a loop as a background in a game and have that be a System Sound API. There's no volume control. The volume is completely dictated by the system volume that the user has set when they go up and down on the toggle switch for the volume. It plays back immediately. There's no scheduling of these sounds. So if you say, play this chirp sound, it's going to play right away. In fact, if you say play this chirp sound and it's in the middle of playing another chirp sound, it's going to interrupt the existing chirp sound, the one that's playing right now, and it's going to play it again. So it's very immediate sounds is what we're going for. And there are only a couple of formats that it supports. It doesn't do any highly compressed formats. We're talking about AIFF and WAVE and CAF. So these are uncompressed PCM formats, and PCM just means essentially uncompressed, right? Okay, so how do you play with the system sound APIs? Well, the first thing you do is you have to register your sound and get a sound ID back. Then you can take that ID and you can play the sound, and you can, if you want, get a callback for that sound ID when it's done playing. Here's how you do it. Let's say you have a URL. You know where your sound is as part of your bundle. You call this audio services, create system sound ID, and you pass in the URL, and it will return to you, I believe it's an int32, but it's the system sound ID type that you'll get back. Then when you want to play it, you pass that ID down to audio services, play system sound, and you're done. When you're done with that sound, so you may want to keep that sound around for a little while. Let's say you have this alert that you play often. You may just want one of these. You can keep it around for the duration of your app. But when you want to dispose of it, when you want to move on, you can have several of these existing at the same time. But when you want to clean up, because we're all good citizens, you're going to call audio services dispose system sound ID. And also memory warnings, which you've heard us preach quite often. Because these are pieces of data that you can get back at any time, the URLs tend to be from your bundles, then we would encourage that you dispose the sound as soon as you get a memory warning, and then just recreate it when you need it again. This is also how you do vibration. So on the phone, there's a vibrator. If you toggle the ringer switch, you'll feel it. If you mute your audio and you get a phone call, you'll feel it. You can actually trigger this programmatically as well. The vibrator has a system sound ID of its own. And you pass that in, it's system-wide. You pass that into audio services, play system sound, and it'll vibrate the phone for some fixed amount of time. Half a second, I think. Maybe more, maybe 0.75 or something like that. But if you want to do, if you're making a game and you want the phone to vibrate because they just ran into an enemy or something like that, then this is how to get that physical feedback to the user. Now, not all sounds are AIFF and WAVE, and there are tons of audio tools on the market. There's actually there's a command line one that comes with the Mac that would help you convert any sounds you want to AIFF and WAVE. And it's AF convert, supports a bunch of input and output files formats. If you do user bin AF convert -H, it should tell you all the arguments that you can use. Or the man page will work as well. But it'll help you convert any of your sounds to system sounds so you can include into your app. So here's an example. AF convert -F means that it wants AIFF. -D means it wants an int16. The BEI16 is an int16 format. Input MP3, so it takes an MP3 in this case and generates the AIFF on the way out. Okay, so that's the system sound API. Pretty simple, not too powerful, but not intended to be. When we go a step further down the path of complexity, we look at the AV audio player. An AV audio player, it will take longer sounds. It basically takes a URL and it'll play that. And you can have several of them running at the same time. It can be files that are stored on disk or in memory. It'll actually, if you have something that's on disk, it'll actually stream that off the disk for you in an efficient manner as it needs it. You can do transport controls on it, so play, seek, pause. You can get metering information. So if you want to throw up audio level meters, right? You're generating some sound. Sorry, you're playing some sound, and you want to show like the amplitude going up and down. You actually get, I think it's callbacks for the metering information. Again, you can play several of them together. It's Cocoa APIs, so all stuff you're familiar with by now. And it supports a lot of different formats. So the audio file API is something that is part of the audio toolbox, and I'll talk about audio toolbox in a moment. But the audio file API has built-in support for a couple dozen different audio formats. Anything that supports is supported by AV Audio Player. Here's an example. So if I have a path in my bundle that's let's say a piece of music. I call path a resource. I turn that into a URL, stuff we've seen before. But when I want to initialize the player, I say init with contents of URL. I allocate and then init with contents of URL, and I have an AV audio player. Now I can start playback. I can pause playback. I can change the current time of playback, and we'll see a demo of this in a moment. And again, you can actually set yourself as the delegate for the audio player. So the delegate methods that will come back are, it'll tell you when playback is done. It'll tell you when playback stopped. It'll tell you when there are decode errors. So if there's like a poorly encoded MP3 that for some reason it just can't parse, it'll tell you about that as well. And it'll also give you these delegate callbacks for interruptions. So if you get a phone call, remember I said the system is who really owns the audio here. If it interrupts your audio, it will tell you. So if you get a phone call in the middle of the song that you're playing, it'll tell you. And you can choose at that time to pause playback, and then it'll tell you when the interruption is done, and then you can resume playback, which might be a little more elegant than just letting it, if you don't respond to them, I think it'll just keep playing. It'll actually be silenced, but it'll keep playing, so your time will have moved. And actually, if you think about, if you ever play a podcast or an audiobook on the phone, and a phone call comes in, you want that thing to stop, right? Because if I lose 5 minutes in an audiobook and then I have to seek back and forth to find it, it's a pain in the butt. So respond to these interruptions. Yeah. So audio sessions. We've already had some questions on the forums about this, but there are different ways that your application can deal with audio. Okay. You may want to play audio even though the ringer switch is off. You may want sorry. Okay. If you may want your audio to keep playing when the ringer switch is off. You may want to pause the iPod's playback. If the iPod is playing when they launch your app, you may want to stop that. You may want it to continue, right? So let's say you're making a piano app where you want to play back to something on the iPod, that's a case where you want the iPod music to keep playing and you want to throw your sounds on top. So the way the system solves this is it has a set of audio sessions, and they're categories. Basically, there's about 6 or 7 of them, and you can say that your app is meant for playback and recording, it's meant for just recording, it's meant for media playback, or it's meant for ambient sound, right? And ambient sound, I think one of the properties there is if you're playing audio and you tell the system that you're an ambient sound, when the user locks the device, it'll actually stop playback. So, a few different ways to do that. Take a look at the enum for audio sessions. And if you're doing any audio, especially in your final project, take a look at those, because you'll want to specify one or you'll get the behavior that you don't want. So we'll do a little demo. Oh, right, default sessions. So, one other thing to say here about sessions is you can actually customize them any way you want, and there are a few different properties that you can set up. But there are a few default sessions that you can go with. You can tell the system to mute other sounds when you play yours. All right? Again, so if the iPod is playing, you may want it to mute when you start playing. So you can tell it specifically to respect or not respect the mute switch. And then the ambient example I gave is a case where they say, yes, mute the audio when the user locks the device. So yeah, take a look at those. Yeah?
What's an example of when you would not want to respect the mute switch?
Question is, what's an example of when you may not want to respect the mute switch? Well, that's your policy decision, right? So if you have, you may have seen some games, they keep playing audio even though the ringer switch is off, right? Yeah, I don't know. I like to use the ringer switch to turn it off, but you also have the volume controls, right? So, yeah, I guess I don't have a good example for that.
I just read something the other day that said what our policy was officially. I'll find it.
Yeah, I guess so. Josh was saying that there is a policy for when you should do that. That check the website and I can find out more. Okay, I should give this away. So, what's the API to use for short sounds? Yeah.
System sound API.
Hey, somebody's taking notes here. Okay, so here I've got an application that has a couple view controllers. The video view controller we'll get into in a little bit. First thing we're going to look at is the audio view controller. Let's pull up the nib. So if I go into audioview.xib, you'll see there are a few buttons here. There's play short sound, there's play long sound, and then there's skip back and skip forward. So I'm going to hook those both up. The play short sound is going to hook up to System Sound APIs, and the play long sound is going to hook up to this one's AV Audio Player. Who said that? Okay, so that's our nib. Let's go into Xcode and see exactly what's implemented here. So we start off, that's the video view controller. We go to the audio view controller. And here we have a method. Let's look at the header really quick. So we have a couple of IB actions here, a few here. We have the play short sound. All of these correspond to the buttons play long sound, skip forward, skip back. And let's look at the implementation. So in our play short sound, so when I click that play short sound button, it's going to call the play short sound action here. It's going to get this twang.caff out of the main bundle. It will create a system sound ID from it. And then it's going to play that system sound right away. Yeah, that's that. So let's run. Oh yeah? You can give me the brief and I'll fill up people in. So we have the policy for when you should and should not play audio during the ringer switch. So we're going to find that out for you. Okay, so here I'm going to play the short sound. All right, and you just hear it once. Okay. Now when I play it several times in a row, you actually hear it interrupts the previous time that it plays and starts it playing back immediately. Right? It's going to be a cool hip-hop sound. Anyway, I can't rap.
What's the why CAFF? I've never heard of that format.
Question is why CAFF? I don't know. I don't know why, but I have a love for AIFF. I don't know why. It's just a preference, I think.
Oh, but what is CAFF? I've never heard of that.
Yeah, I don't know what CAFF is, or what the difference is between that and AIFF. I know AIFF in a wave, I believe, is an Indian swap. I'm not sure what the difference is with CAFF. Okay, so that's the short sound. That's the System Sound API. Do you want to jump in on the ringer switch? All right, here. Josh is going to tell us about why we need to use, why you might want to play audio when your ringer switch is turned off.
So, as Al said, there's actually quite a large explanation on developer.apple.com, but the brief explanation for it is you don't want to play sounds that would interrupt the user sort of unintentionally, things like keyboard clicks and stuff that they probably don't want happening when they want the device to be silent. But you do want to play sounds that resulted specifically from user actions that were specifically designed to play sounds, like playing music or setting an alarm on the clock, things that the user actually asked specifically they want a sound to play. So when I go to bed at night and I have the alarm set and I have the ringer switch off, it's still going to go off? It will still.
Okay, because I'm really freaked out about that. There's too many times with my regular alarm clock where I've set it off by an hour, turned the volume down, and okay, that's good to know.
Yeah, even with the ringer switch on, your alarm still plays.
Is it? Okay, so there you go. There you go. Josh gets a sketchbook. All right, so now we're going to look at the play long system sound, right? And we'll see what that does here. Let's look in code. As you can imagine, I don't need to show you the nib, right? It's all just wired up. The buttons go to the IB actions. You should be familiar with that. So play long system sound. What we do in here is we're going to, we have a song that's embedded in our app bundle. And it's you, me, and love.mp3. So we get the URL for that. And then we initialize the AV audio player. We get a player back. And we set ourselves as the delegate. Then down below, if we're playing, we're going to tell the player to pause. And if we're not playing, we're going to tell it to play. Player is an instance variable for the class. So here we only create it once. So if I keep hitting that button, it's not going to recreate the player, but it will come in here and toggle the play and pause. Now for delegate methods, so, well, we actually can't demonstrate this because I'm on a computer, not on a phone. But what we do with the delegate methods is when we get an interruption, we're going to tell the player to pause immediately. So if somebody calls me and I'm listening to a song through this app that I made, the audio will pause. When the phone call ends, we get the end interruption, callback, the delegate method, and we tell it to play again. So, yeah.
Can't you simulate it by like pushing that menu option that says like simulate lock? Is that considered an interruption when you lock your phone?
Question is, when you simulate the lock in a simulator, is that an interruption? And I don't know. Let's try that. Let's try that. In fact, I wonder, you can simulate phone call. I wonder if that's actually, if that does it too. Let's give it a shot. Okay, and then another thing down here, so that's our play long sound. There are two other methods here. There's the skip forward and skip back. Right, so what we do in the skip forward is we take the current time of the player, we add 30 seconds, and we assign that back to the current time of the player. And in the skip back, we subtract 30 seconds. So I can scrub forward and back. Yeah?
Does that truncate at the end of the ends of the clip?
Right, question is, does that, so if you go beyond the 4 minutes or whatever the song is, does it truncate? And yeah, it does. It knows the length of the audio that it's trying to play, so if you go too far, I believe it actually stops it for you. So if you, if the song's 4 minutes and you go to 4 minutes and 15 seconds and then you try to go back, it's done, stopped. So let's do that. So we're going to play the long sound. All right, it's the beginning of the song. Cool little piano intro. Skip forward 30 seconds. Nice little trombone. I know there's a part here where there's a trombone solo I really like, so I think I skipped forward too far. Oh, something's happening. It's pausing. Anyway, if I toggle this button, as you remember from that method, it's going to toggle between play and pause. Pause. All right, so pretty simple stuff, right? There's 30 seconds forward. I don't know why that's happening. Yeah. Okay. What I want to show you is another way you can interact with this, right? So this is a fixed 30 seconds forward and 30 seconds back. Well, we can do a little more fine scrubbing, right? Scrubbing is basically being able to manipulate the time. So let's add a slider. Go into our nib. Let's hide that. So let's put a UI slider. And this is going to be our scrubber. Now we'll go back to here. We'll say, we'll add a new action, which is IB action scrub. And we're going to take the sender. Right? We're going to know that the sender is a slider, conveniently. And it's okay to make that assumption. If you know that you have one view that's calling an IB action, it's okay to know that that's a slider. So UI slider equals, we're going to cast the sender, slider, sender. And what we're going to do is we're going to change the current time to be the player duration, times the slider's value. Right, so I'm going to take whatever the duration of that song is, and I'm going to multiply it by a number from 0 to 1, which is the slider value, and we're going to set that as the current time. So here we'll hit run. I'm going to play. Oh, why is that not showing up? Right. Audio view. Strange. Well, one thing I needed to do here that I forgot, and I always forget, is to hook up the slider as to the scrub action. And let's kill it and run again. Okay, so here we have our scrubber. It's hooked up to the action. When I hit play, it's going to play. Right. And actually move that guy around. And for some reason, it's pausing on us. But when I move it a little further and keep it going, what the hell? Anyway, you can kind of see. Don't know what's going on here, why it's pausing, but when I move the slider to a new location and I hit play again, it's at the different place in the song. Oh, come on.
Problem with the simulator, clearly.
Of course. Yeah, it's a problem with the simulator. That's strange. All right. Well, you can, if you can trust me, this is how you implement scrubbing. You should be able to, and yeah, you can get the duration off the player. Yeah. All right. Failed demo number 1. How many more we got? So let's keep going. Let's talk some more about audio. There are a couple other. Yes. Yeah.
Question about the scrubbing. How would you set it up so that it actually also indicates where you currently are in the song?
Good question. So question is, if you have a scrubber that goes from, let's say, 0 to 1, how do you have that scrubber move along with your song? Does anybody want to take a guess on that? There are a few ways to go. Anybody want to take a guess on that? Yeah.
I mean, can you update the slider value as the progress is to the duration of the song?
Yeah. So your suggestion was, can you update the slider value with the progress? I don't think AV Audio Player gives you that as a callback. But some of the other APIs do. Like the audio cue that we're going to look at, it actually does. So you would get a callback that said, I'm now at time 15 seconds, and then you can convert that to a spot on the slider. Another way to do it, which is actually in the remote app, the way we do it there, because we're network driven, we want to keep network traffic down. We actually just start when we know what time we're supposed to be at, we start a timer. And then every half a second or full second, we'll go and advance. We'll tell the slider to move to a different value. So, and then when in the remote's case, when iTunes says that it has moved to a different time, we go and we reset the timer and we set the new value and we start the timer back up again. So, yeah, the AV Audio Player again. So it wouldn't give you that callback. Audio Cue would, and this is where we start getting into some more sophisticated APIs. So. The Audio Toolbox framework gives you several different classes. The one we're going to look at today is the Audio Cue. But this will let you do something that a lot of people are really interested in, which is network audio. So what Audio Cue does is it's a way for you to feed buffers of data to the audio playback engine. And so if you're generating audio, you can generate your sine wave or whatever audio you're generating. In consecutive buffers, you feed that to the cue, and then the cue will play that for you seamlessly when you tell it to play. If you can get a few callbacks. I think I have a slide on the callbacks. No, I don't. So you can get some callbacks to know when a cue when a buffer has been completed. It will give you a chance to reuse that buffer. So instead of having to allocate all these buffers over and over and over, if you have, say, a fixed size buffer that you're working with, you can allocate it once, tell it to play, and when it's done, it'll tell you when it's done, and you can use it for whatever you need it again. So, yeah, and again, it'll let you do. So the AV Audio Player would only let you do local URLs, right? It won't let you specify URL in the cloud, but the Audio Cue stuff will. So. If you feed it a URL for, say, some streaming website that the Cue APIs support, it'll actually take care of all the HTTP traffic and pull it down for you. So now audio units is another way of doing audio processing. This is, again, audio units under the hood is what a lot of studios use or what a lot of professional applications use for audio processing. The parallel to audio units in the real world is studio equipment, right? Music equipment. If you've ever been into a studio or if you've ever seen how these things are hooked up, it's several different boxes, right? Each one, like you have an effects processor, you have a synthesizer, you have a reverb. You hook all those together. You can have several of those, hook them into a mixer, And then the mixer takes several tracks. It'll mix them in certain ways. The mixer has EQs and levels and all that stuff. And then the audio units can have outputs as well. So they're these processing nodes that can have n inputs and n outputs. And they'll process audio in whatever way you tell them to. So, as an example, I could take an audio input unit, which I'm going to feed buffers to, and then I can pass it to a reverb unit. And that reverb unit can feed into a mixer, and that mixer can take 2 inputs. And on the other input, it takes, let's say, input from the microphone. And then you're going to add an echo unit to that and feed that into the mixer. So you have what you just built there with those audio units is effects audio, microphone effects processing engine. If you ever seen like the T-Pain app, that's done through audio units. I believe they wrote their own audio unit for doing the auto-tune. Right? Everybody knows what auto-tune is because you hear it on the radio every day. That's down at the audio unit level. That's how they do that stuff. So again, very powerful, and this is what the studios use. So this is really useful if you want to do DSP. The last one I want to talk about here is OpenAL. So again, OpenGL is all about rendering 3D, right? You specify objects, and the objects have points and shapes and textures. OpenAL is very similar in that you specify point sources of audio, you specify a microphone, and based on you specify an orientation, right? So if a piece of, let's say, an audio source moves in space, what it will do is it'll re-render the audio to fit the head, right? There's the way we, as humans, the way we recognize spatial sound, the way we can tell that dog barking is from over there and that door slamming is from over there, is by taking the phasing of the sound and the time difference. It's a split second, but the time difference between that door slamming hitting both ears. And OpenAL will actually synthesize that. So if you take you have a virtual door slam and you say that the head microphone is here, if the user is wearing headphones, it's actually going to sound like it's coming from over there. So I believe there's effects processing as well. There's textures, so you can tell it that it can bounce off metal, it can bounce off wood, stuff like that. And I'm by far not an expert on the OpenAL stuff, but if you're interested in that stuff, or if you're building a 3D game and you want to get really sophisticated with audio for your final project, or even just general interest, go take a look here at openal.org, and they'll tell you a little bit more about it. That was audio playback. I want to talk a little bit about audio recording now. There's 2 different ways you can do. Yes?
Can you access iPod library?
Question is, can you access iPod library? And yeah, I will get into that. There's limitations on it, but we'll get into that. So the AV audio recorder, right? So you want to input sound. There's 2 ways to do it. The first way is with AV audio recorder, and this is very much a parallel to the AV audio player. It's a COCO API, very simple API, and some delegate callbacks for understanding when recording began and stopped, and you got interruptions. It does provide metering, so you can find out. Let's say you want to listen for microphone input. You can show amplitude meters to show what when the person is speaking, when they're not. And it does sample rate conversion and format conversion as well. So you can specify to the AV audio player that you want to init with settings, and those settings are different audio formats. So here's an example of that. So you actually create an AV audio recorder with a URL. And that URL is, of course, it's not the source, because you're recording. It's the destination. And the AV audio player will append the data to that URL. I'm going to pass in nil for settings, but I could have passed in, I believe it's a dictionary. And that dictionary could have properties for sample rate and format, compression, stuff like that. And you can get an error out in case there was a problem. For recording, right, you can say, let's say just like in our example app where we were toggling the playback and pausing, we can do the same thing here where you can record and you can pause. So, and as you record, as the queue fills up, it's going to write those things to disk. Here are the delegate methods. Well, here's just a list of what you get back from delegate methods. Again, very similar to AV Audio Player. You'll be told when the recording is done. You'll be told of any audio encode errors, right? Encode errors rather than decode errors. And there's hooks for handling interruptions. The last way of doing audio recording here is with, again, it's actually the audio queue APIs through Audio Toolbox. And you can actually tell your audio queue to get set up as an input queue. And what will happen then, instead of feeding the queue buffers, it will feed you buffers of audio, filled with whatever came in from the microphone. So you create a queue, you define the callback function that you want to call whenever it receives data. You start the queue, and that'll start recording. And then it's up to you, actually, with these APIs to do the storing onto disk. So if you want to, you actually don't have to store it to disk immediately. If you want to process that, if you want to do the T-Pain app, you may want to take these buffers and feed them back into an audio unit graph that'll do the auto-tune or whatever. Don't do auto-tune. It's been done. Find some other effect and do that. If you want to, actually, there's a great example, which is the Speak Here example on Apple's developer site. So go check those. Okay, so this is where I want to talk a little bit about how do you get iPod playback. Yeah?
One question. So how do you know how much space you have for storing your audio? Is there a limitation on the amount of space that an application gets?
That's a good question. Josh, do you know? Is there a limit to how much space your application can use for storage? And do you know when you're approaching that? Yeah. Not sure. I would bet I don't know the answer. But I think you may be able to find that out through the NS File Manager to find out how much space is left. I'm not sure, actually.
In this case, you basically just give a URL within your application and
Right.
file gets stored there.
Right. So the question is, well, where do you store that data? And as an application, you have access to a few different places to store. Right. You're mostly locked in. We talked about the sandbox a little while ago. You're mostly locked into a few locations in your application. Right. So every application actually gets its own user hierarchy. It gets a documents folder. It gets a cache folder. It even gets its own temp folder. And you can write to those areas. It gets a library folder as well. So if you're familiar with those folders and how things are stored on the Mac OS, it's very, very similar to that. But it's all within your application. So if let's say you're recording, that actually also means that you can't record something and have another application use that recording, right? So you're limited that way. But any other questions about recording or playback? Okay. So the media player APIs, media player framework. This is how you get the iPod to play back music. So you have access to the entire iPod music library. Audiobooks, music, podcasts, I think those are the three types. And you have access to play back those items. You don't have access to get the data for those items. And if you think, part of the restrictions here is that some of that music may be DRM'd. Now, sure, Apple got rid of DRM middle of last year, but some of that data is not accessible. And of course, they don't want applications going and ripping files. So you have access to the library insofar as you can tell the iPod application to play it for you. And as we talked about with the audio session categories, the iPod can play in the background for your app. So if you're building that music player app, the piano player app where you're going to play on top of it, you can have the user in your application go and pick a song, and then you can generate your sounds on top of it. There are a couple different ways to get to this. One is through a very simple view. I think it's a view controller, the MP Media Picker controller, which you would pop up as, say, a modal view, and that will actually automatically be configured to have the user's library there for you. And then when the user picks one or more songs, it'll call you back, and you can do whatever you want with those. If you want deeper access, let's say you wanted to build your own application that does custom filtering of the iPod app. I know there's actually a former student of this class built an app that basically it was an iPod app, but only for albums, only for music that you had entire albums for. So kind of interesting. Or I think it was maybe 5 tracks or more per album. And they didn't show you any tracks that had fewer than 5 tracks for that album, if that makes any sense. The way you would do that is through the query API. So the media player framework gives you ways to query the database. Here's the MP Media Picker controller first. So you can initialize it with, here are the different media types you can use: music, podcast, audiobooks. And I'm pretty sure this is a UI view controller. You can actually get that and put it in present it modally, right? As we talked about, either you can put it in a navigation controller, or you can just say modal view controller, present, something like that. You can specify whether you want it to allow the user to pick multiple items. And if you say no, then the first thing they pick is going to close it, and you get a callback. If they say yes, then they can choose several items, and it may have check marks or something next to it. And you can also provide a prompt. So actually, this must already be embedded in a modal view controller, but you can allow it to prompt in the nav controller. And the delegate methods, well, you can know when the user hit cancel, and you can know what they picked if they actually successfully went through. And what it actually returns is an MP media item collection, which we'll see in a moment. In fact, we'll see right now. MP media item collection is a set, it's an array of MP media items. Okay? MP media items are tracks, we'll look at that in a second. But MP media item collection is actually also used to represent playlists. So you can ask the library for playlists, and that's a bunch of MP media item collections. You can ask it for albums, and that's a collection. And here are some properties on it. So you can get a collection, and you can get the items off of that, and it'll return you an array. You can ask for the count. You can ask for something called the representative item. And if you have, let's say you get a playlist that's a Genius playlist, the representative item would be the song that was used to create that Genius playlist. If you had any other kinds of collections, I think for an album it might return the first item. For a playlist it might return the first item. But there's some smarts in there to know what is the MP media item that represents this collection. And MP media item collection, because it's an array of types of MP media items, may have one or more types. So it'll return this enum to you. It's actually a bit field mask. An MP media item, well, this is, it's a property-based, there are only 2 method calls on it. One is can filter by property. So you can ask it, are you able to filter by artist? And then you can also say, you can get, I think so there's can filter by property, and then there's value for property. So there are several strings you can use. You could say value for property, MP media item type artist, MP media item type title. There's several lyrics, right? You can get the lyrics off of a song. Yes?
Is that metadata just gettable, or can you also set it?
I believe, so the question is that gettable or settable, and I think it's just gettable. So you don't give, I don't think there's any write access to the iPod library. I think it's up to the user to write that through iTunes. So, yeah. All right, so here are different classes that are available in the media player framework. There's the MP media library, which represents your entire library. There's the query, the predicate, and the property predicate, which allows you to, you can build predicates and then query for that. So if you want all Lady Gaga songs that are greater than 3 minutes, you can build that. In fact, maybe you can query the lyrics for, anyway. And then an MP media item artwork, you can get the artwork from a media item as well. All right, so that's it for audio. I'm going to move on to video now, unless there's any questions before I do. Yeah?
There's something where you want it to be like playing live. Like what's the, but you also want to do some audio processing. How fast is the feedback?
Okay, so question is for if you want to do some audio processing and live playback, what kind of time, what kind of latency do you get? And the audio unit stuff and the audio queue stuff lets you specify your buffer size. And if you think about how these things are processed, so you have to fill a buffer before you can pass it to the queue, right? So, and you only have to be one buffer behind at a time. I mean, so as long as you have another buffer there by the time that the first one's done playing, you're fine. So if you take, on the Mac, it's pretty standard for people to use 512 samples in a buffer, which at 44.1, I think, 44.1 kilohertz is about 11 milliseconds. So if you have, if you use a small buffer size like that, which is a reasonable buffer size, you're looking at 10, 11 milliseconds for latency. So 10, 11 milliseconds is in the range of not noticeable. When you start going up to 20, 25 milliseconds, people can tell. Like it just sounds a little bit off, right? If you think about video, right? If audio is off by a frame, people can usually tell a little bit. If it's off by 2, 3 frames, now we're talking 90 milliseconds, and it just looks wrong. So video playback. Lots of reasons you might want to play video in your app, right? You may want to provide a cutscene for an animation. There's a game called Crash Race Car or something like that, where when you finish the race, it'll pan the OpenGL over to a specific view and then show an actual video animation that it created that seamlessly transitions to the menu or to the next scene. You can stream content from websites. So let's say you're making the Olympics app, and you want to stream video that's on your website. You can do that. Or you may want to play local movies, right? So yeah, that's pretty self-explanatory. A few restrictions on the video, right? The video on an iPhone is not embedded in a view. Every time you play a video, it's full screen. And there's a reason why they did that, right? If you look at the iPhone, right, you're all familiar with it, we're talking 2.5-inch screen here. If you had to, if the video is embedded in some other view, it's so small you can't even see it. So every time you play video, it's full screen. You have some options for how it's scaled. You can tell it to fit the aspect ratio, or you can tell it to fill. And you have some controls that you can optionally show if you wanted to, like volume controls and transport controls. And these may have expanded since that was true in 2.0. I don't know if 3.0 is any different, but it supports .mov, which are QuickTime format, .mp4, .m4v, and 3GP. Right? So those are your video formats. Here's your controller. So when you want to say play a video, this is your interface for it, MP Movie Player Controller. You initialize it with a URL. You can tell it to play and stop, and you have a few different properties. You can have the background color. So if your video doesn't fill the screen, you can tell it to fill the rest with blue if you wanted to. Scaling mode, right? That's the aspect, fit or fill. And the movie control mode, which is, there are only 3 choices. There's no controls, there's volume only, and there's volume and transport controls. So if you want to allow people to seek, you would say, the default. And if you're streaming and the user can't seek, then volume only. And there's notifications that you can respond to. You can know when a movie is about to start playing. When it's done, you can know when the user changed the scaling as well. So a quick demo. So let's go back to our app here. All right, and here I have just 2 buttons this time, play with controls and play without controls. Let's look at the code for that. So I have 2 IB actions down here. One is the play video with controls, which then calls into another function, which we'll look at in a moment, right? Which just says yes to show controls, and it loads. This is actually a website, right? CS193P Stanford ad. Ooh, is that up? Okay. And then play video without controls is a local movie that it's going to play. So we're going to say yes or no for the controls. But let's look at this play video with URL. So if we haven't already allocated a player, we're going to allocate the player and init with URL, which is the URL that gets passed in. We're going to listen for notifications for did finish playing. And I'll show you that in a moment. And we'll just set a couple properties here. If controls is off, then we're going to tell the scaling mode to aspect fill, which is, let's say you've got a cinema-wide movie. Aspect fill will say fill the entire screen, don't show any of the black bars. Versus aspect fit would say fit it in so you can see everything. And the movie control mode in this case, so if no controls, then it's going to be hidden. And if not, we're going to go with the defaults. And the defaults are the controls are there, and the scaling mode is fit, aspect fit. Now let's look at the callback. So when the movie's done playing, actually all we're going to do here is remove the observer, but of course, good citizens, we're going to call player release. All right, so let's go to the video tab. And let's start with play without controls. What you're going to see here is, because it's full screen and most video is landscape, we're actually going to see the simulator rotate. So there it is. Right, let's do it again. And I can click on it. Nothing happens, nothing comes up. Okay. Now, this one I'm wondering, I may have a problem with because the internet connection, but if I say play with controls, see if it works. It's trying to load it, can't find it. So let's actually, let's just use the same URL that we had for the local one. Right. So we're going to play this again. This one's going to have controls. Let's go to our video tab. Play with controls. And this one here has, when I click, the controls come up and they go away. I can scrub, right? I can pause. I can hit next and previous, though this isn't really going to do anything for us because it just ends the movie. If I hit back, it would just scrub to the beginning. Actually, it stops it as well. So that's video playback. It's pretty simple. There's really, really actually not that much you can do with it. But there is something else you can do with video, which was new to 3.0, and that's video editing. If you look at the iPhone's Photos app, you can toggle, if you're running a 3GS or later, I believe, you can actually toggle the camera to be a video camera instead of a still camera. And if you do that, once you've recorded your clip, it'll actually give you this touch API for trimming your clips. Pretty cool. It means you're out water skiing and you're filming your friend and they take a spill and you want to post it on YouTube. Right there, as you're filming it, you can trim it back to just the spill and post that online. So API for this is pretty simple. So why would you do it? Well, maybe you want to post to YouTube, right? Maybe you want people to be able to record and post. Or maybe you want to make a video editor. And I haven't seen anybody do a good job. I have heard there's a video editor that's pretty cool. I haven't played with it yet. But they're using this API. And so you use as Josh mentioned last week, we talked about last week, the image picker controller. So you can throw up the camera, and the camera, like the still camera and the video camera APIs are actually identical. I believe there's a flag on the image picker controller to say whether or not it should be video or not. So you record with the image picker controller, and the formats that it can output are the same as playback. So MP4, M4V, etc. Here are your APIs. So you can ask the video controller if it can edit a video at path, right? So let's say let's say you have some video that's, and I don't know, maybe there's some formats it can't support. I'm not sure why this would return no. But you can ask the video editor if it's able to edit a video. Then you can instantiate one. And this is really, it's just a subclass of UI view controller. So you can push it on to your stack just like any other video or any other view controller. You feed it the path. You feed it the maximum duration that you want it to be. And then you just hit go. You push it. And what will come out the other end will depend on the delegate methods. So the user will have all the trimming API that they have with the cameras app. And once they hit save, it'll call you back to save that to disk. And the actual function you use to save escapes me, but it's like UI image video save video at path video or something like that, right? Yeah, it was really, really long. It escapes my mind. But all right, and you can find out when it failed, and you can find out when the user canceled as well. Right, that's actually it for video. Right, there's only those two classes, and of course the UI image picker controller for actually doing the recording. So the last thing I want to talk about is how do you embed application settings into your app? How are we for time? 10 minutes. Okay. So applications, as you well know, there's a settings app on the device, and each application can actually register a bundle that becomes its settings in the settings app. The trick with settings is to do it sparingly, right? So you don't want your users flipping back and forth between your application in order to go toggle some settings. In fact, if you look at the way Apple writes their apps, the settings, unless you're talking about mail where there's a lot of configuration, the settings tend to be pretty minimal. What I encourage you to do is if you're thinking about settings for behavior, is to come up with the right behavior and dictate. That's the way it's going to be. But if you're looking at settings for configuration, for user configuration, that's kind of more appropriate for what you want to put in settings. Right? Don't put in every switch just because it's available. Maybe you want to do this for debugging. You don't want to do this for shipping apps. Well, how do you build these, right? So there are two ways to go about putting settings in your app, right? Number one is to put it in the settings app, right? These are default behavior overrides, and they're things that you don't want your users changing that often. In fact, they probably have some preference of the way it's going to behave. They'll want to set it up once and leave it that way. All right, again, examples are mail account information, right? I'm not going to change my mail accounts frequently. And Safari search, well, do you want Yahoo or do you want Google, right? You choose once, and it's that way until you decide sometime down the road you want to change your mind. The other way you can do these is you can embed the settings in your application itself, right? And you see this a lot more with games where you're changing, let's say, audio effects settings. You want to turn on and off the volume. You want to turn on and off sound effects. You want to turn on and off the background music. You want to set the volume, stuff like that. Those things you would want to put in your application. And actually, a couple of advantages and disadvantages here is that if you put it in the settings app, you're not running code when people are changing those settings. It's actually going to set values in NS user defaults for you to fetch. Versus if you put it in your application, well, it uses up UI space. That's a disadvantage. But you can actually run code when people hit the different buttons. If you want to put it in the settings app, you create a settings bundle. And I'll show you how to do this in a moment. Again, for really infrequent stuff, you can put it also in the back of the main view, right? So you can flip over your view. There's actually a flip transition. Right, stocks and weather does this. That's another place to put settings. And I think there's even an info button that UIKit provides to you. So if you want to do that flip, you just embed that button and tell it to start that transition. All right, so let's talk about the settings bundle itself. When you create a settings bundle, it starts with a root.plist. Okay, and that root.plist specifies a hierarchy of settings. and the settings are predefined, so you can have different types, right? You can have a slider type, you can have a switch type, you can have a group type, or I believe it's called multi-value, for when you know, let's say you have 3 options you want the user to choose from, and to get there, they step through one level to see the 3 options. When they choose one, it steps back. That's a multi-value type. And you do this all by modifying your plist, right? By modifying this plist and giving it identifiers for each of these items, you have a codeless way of getting settings from your users through the settings app. Here are the different types that they have. So there's a title, which is really just a text string. There's a text field. So let's say you wanted, I don't know, you want to change their username, or you want to change some prompt that they see every time they launch. Toggle switch, slider, multi-value I described already. Group is similar to, it's another step-in kind of hierarchy thing, but you can have other controls in there. And child pane, of course, comes from a group. Each of the items have keys associated with it. And the keys are how you reference them inside your app, and you specify those keys. So really quick, this is actually the last thing I've got for today. I'm just going to create a settings plist, and I'm going to show you how to modify that to get what you want. So what we're going to do, if you control-click, or you can go into File, New File, there's a template set up for you. So if you go into iPhone OS, Resource, you can choose Settings Bundle. We'll hit OK. And we'll call it Settings Bundle. There it is, right? The only file we care about in here, if you want to do localization, which we'll talk about, I think, in a couple of classes, you can do that. But we're just going to look at the root.plist. So by default, this is what it creates for you. There's a group, right? That group has a text field that allows input. You'll notice there are a few different fields here that you can fill out. You can say whether that's secure. So let's say that's secure. We're going to change the title of this to password. And we're going to change the key of this to password preference. You know, different keyboard types, which we saw with the text input stuff. You know, here's an example of a switch. Here's an example of a slider. Nothing too crazy here. Let's give it a name at least. So title, our slider. Actually, we have a title. We have a title here, so we're going to say enabled. Let's call this our switch. What happens is when you create a settings bundle, it gets embedded in your application. And when the user downloads that application from the App Store, the first thing that Springboard does, Springboard's the launcher app, is it checks for that settings bundle, and it actually puts that in settings for you. So you don't have to run any code to install it. It just gets installed for you as long as that settings bundle is there. So I'm going to run only so that we can compile and put it in the bundle. All right. So if we go into settings now, that should have gotten registered. And here we are, the AVW samples app. And I've got this password text field, which should, you can't see my password. I have a switch and I have a slider, right? Each of these I can get the value from in my app. So just to show you really quick, I'm going to save this. I'm actually just going to quit. And we're going to modify our application so that we take the password preference, and I'm going to make my password visible. So we go into, let's go into our audio view and just put a text field there. Library. Let's just put a label here. And we'll point to it, and then we'll load the preference, and you'll see what happens. So I'm going to put an IB outlet, UI label, password field. And what we'll do is in our view did load, we'll get that preference, and we'll just set that as the text. So do I already have a view did load? I don't think so. So view did load, we're going to say, what was it? Password field dot text equals NS user defaults, standard user defaults, and we're going to say string for key, and the key was whatever we specified in the, I think I copied it, password preference, so that string. And let's just run. Actually, I need to hook that up in Interface Builder. Password field. Let's just run. You can't see my password. So yeah, that's it. It's really, when you set up a settings bundle, it's really it's just accessible through NS user bundles. The keys you set up yourself. You can look through the documentation to see what the different types are if you want to find out more about how to build these things. That's it. That's all I got. I still have about a half dozen of these. If anybody wants one, just come up after class. And yeah, thanks.
For more, please visit us at stanford.edu.